Oh yeah, people are listening to me talk about what buttons I'm pressing. As always, I have some little amateurish noise at the beginning of the intro. It seems. Nth cup of coffee. I feel like I'm on my nth cup of coffee. I also have an amplifier. This thing.
Oh.
And it says it very brightly right here. It's basically like 3 cups in one shot. But I try to go easy on that one. So we are live, by the way.
Very cool.
And I've started this tradition, partly out of my own laziness, where I just get the guest to introduce himself.
Okay.
So everybody, there it is. Everybody, meet.
This is Derrick Stolee. I am a software engineer at Microsoft. I work on the team, the Git ecosystem team, and we're responsible for contributing to Git, the different Windows maintainers on my team, and we also are responsible for VFS for Git, formerly known as GFS, which is how we get the Windows source code on Git. And so we're really focused on performance and scale and the very largest Git repositories.
Very cool. So I'm gonna ask some questions real quick already.
Okay.
Because you said some of those word letter things.
Sure.
VFS.
VFS. Yeah, VFS stands for Virtual File System.
Okay.
For Git. And that essentially means what we do is we have a file system driver that is watching the source directory.
Right.
And instead of weighing down the 3 million files that would be in the Windows repo, we act like they're there, and we actually go and say, hey, what's in this directory? The file system driver says, hey, wait a minute, let's go figure that out. Let's go ask Git.
Gotcha.
And then we'll say, oh, Git says it's going to be these folders and these files. Let's go find them. Then we actually try to read a file and say, oh, what does Git think that file should be? We go get it out of the Git object database.
Yeah.
Lay it down on disk, and then you're reading it like normal.
Okay.
So you're really only getting, you're paying for what you need, not for what the big giant monolith has.
Gotcha. Okay. So always good to get the TLAs and other multi-letter things that mean many words things out of the way.
Yep.
Just had a conversation, not to derail, definitely not on this topic, but I thought it was hilarious because someone said, what does PHP stand for? And I knew it. It stands for PHP something something.
Right. Yeah.
And nobody believed me until I pulled it up on the Wikipedia page. I was like, no, really, it's one of those.
It's like GNU, it's not Unix.
Right, exactly. It's not Unix. I love those, and at the same time, I'm kind of like, it's kind of weird, but sort of fun. The other one that gets me, though, is because it's not actually it's not an acronym. It's not anything. It's SQL. You say SQL. It's not SQL. It's SQL. But they wrote SQL because they didn't want to name it SQL because something else was named that at the time. There was this conflict in it. So they made a fake acronym. It's not really an acronym. So you say SQL. But anything copied off of that, like say CQL, you would say CQL for Sonic Query. Fun with acronyms. It's so weird. Everybody picks all these different rules and you have to figure it out. But so back to Git. That is awesome that you work on that because I know a lot of people, including myself, I'm in Git all day long, every day. I don't even think about it half the time. I'm like, I have a trackpad, I have a keyboard, I have a screen, and I have Git. Yeah, that's like my life every day. I rarely think about, people work on this every day, like the actual code of Git and the actual way in which it works to streamline various things. So it's cool to talk to somebody that's actually doing that instead of just going git commit, git add, git commit, git push, git pull, all that stuff. Yeah. And I also I was informed when I was introduced to you that you even like to talk about Git and write things about Git on whiteboards.
Yes, I do. I'm a very visual learner.
Yeah.
I love drawing pictures.
Yeah.
So that's usually what I need to do in order to explain anything. I need to draw pictures.
Nice. So in that sense, I'm slightly prepared today. As you can see in the corner of the screen, there's a whiteboard, which we will make bigger when you want to write on the whiteboard.
Exactly. When it's time, I'll go draw pictures.
Yes.
What we want to draw first.
Right. We'll get all visual, and you can see our camera focusing fuzzily on that. So it's going to be super cool in just a minute when we get all whiteboard. So speaking of Git and working on Git, what are some of the latest, newest things that you've been working on, especially that you find yourself interesting?
Yeah, I can say that the biggest one I've worked on is the commit graph feature.
Mm-hmm.
So the commits have a history of following parents. They form a directed graph.
Mm-hmm.
And that's sort of this abstract data structure that's happening in the background. But what I did is I put a more concrete structured data into Git so that we could parse that really quickly and do a bunch of graph algorithms on that and sped up a lot of things. So really, really important for the Windows rebuild because it has formula commits in it. It's just a bit. Yeah. For perspective, the Linux kernel repo existed for 15 years or so. So about 750,000.
Oh wow!
And the Windows repo, this is what they got 2 years.
Yeah.
Because that's what happens when you have 4,000 engineers using that.
When it's like 60 million lines of code or something.
Yep. It's very big. Yeah. So there's a lot of movement, a lot of files being created, things like that. So having people be able to do history views, getting history is very important, or be able to find a merge base,
right,
or do a rebase. All these things you get faster. You can operate.
Yeah, for sure. So you mentioned graph. I'm a big fan of graph. In many ways, especially even like where I work, we have a whole graph system built onto Apache Cassandra, our data stack enterprise solution. I don't know, it's not the same thing, but it is similar-ish to GitGraph. Would you want to elaborate on that specific feature and what you worked on?
Sure.
Could you draw it out some?
Yeah.
Cool, let's do that.
All right.
So, give me 2 seconds to hit the button and for him to walk around the table to the whiteboard.
Well, let's be off the focus.
Well, look at there. You can see the whiteboard now.
Here. Very cool.
Awesome. And as always, if any questions pop up, just put them on the screen and I will make sure everybody in the room gets to see the questions or the comment or the whatever opinion you have.
Yeah, let's talk about what people are interested in, but let's start with what I know to talk about.
Exactly.
So, we have a commit like this. I would draw it with a circle. See it's working at a circle. And it usually has a parent, which is the previous point in time.
Mm-hmm.
And so these edges, commit the parent edges form the graph. Sometimes you'll have multiple parents. For instance, if you're in a merge commit, you have this arrangement here. Now, when you want to do something like a merge base, then I have some commit A and some commit B, and they've got some set of parents that they're working on, and you want to follow this graph down until you get to a point where they have some commit that's in common, that's reachable from both of these. If you follow it, 1, 2, 3, 4, I can do that. 1, 2, 3, 4, 5, I can get to that. There may be multiple ways to do it.
Mm-hmm.
And the way I try to mark this out is by doing here's the reachable set from A, and here's the reachable set from B. And what I care about are the things that are in the common space, where both A and B can reach them, and we want to be kind of at the top of possible. Yeah. And that's what you do when you run Git merge base A to B. This is usually not something you would run directly. It's not something that happens when you're doing something like I want to merge A into B.
Right.
I want to do rebase. You'll find merge bases. Because if you rebase on B, you can find out, hey, wait a minute, what is new in the A branch that's not in B? You actually find out what's the first thing in common, and then you take all these things and this something different than the rebase. So how do you find this efficiently? Because say, A and B aren't that far apart,
Right.
but there's actually thousands or millions of commits way down here.
Mm-hmm.
And so one basic algorithm you can do is let me just walk everything from A and give each commit a saying, hey, I can reach this from A, I can reach this from A, I can reach this from A.
Right.
And then walk everything from B and say, I can walk this from B, walk this from B, reach this from B, until you find something that has both.
Mm-hmm.
And then, because of crisscross merges, you want to be careful that you might get multiple answers, multiple potential answers. You want to make sure you're getting the one that's not reachable from any other. And so that makes it kind of tricky. But you see how I've laid it out. I've kind of drawn all of my parent edges backwards, or again,
Yes.
which corresponds to time with this one.
Yes. Yeah, because you got like 2 forward-only read paths, and you're looking for the commonality point. So yeah, gotcha.
So if I were to say, let me explore by commit time,
Mm-hmm.
and so I'm always trying to keep on the newest commits.
Right.
As you go, you can say, oh, well, these are the newer ones. You would explore it by saying, first we do this one, and then we explore this one, and then I see that I can explore this one and this one in that order, kind of doing a breadth first search.
Right.
But instead of actually using breadth first search, you're using a priority queue based on commit.
Mm-hmm.
And as you go, you'll essentially get to a point where, hey, I see this one, and it's the one with the most recent time.
Right.
That has both reachable. There's a problem with this. The problem is that you can set your commit date to whatever you want.
Mm-hmm.
When you want to get commit, it will use your
Yeah,
system
no.
time to
Yeah.
pick out what that commit time is. So it's a thing where, yes, there's clocks due to machines, and so you can get off by a few seconds when you're doing really quick commits.
Right.
But there's also, you can environment variables set to whatever you want. You set epoch to
Yeah.
you can set so there's all sorts of places where the commit date is backwards, where my parent is actually newer than me, and that can make this algorithm return incorrect results.
Right.
If you are trusting commit date.
Mm-hmm.
And so one of the things that I was able to do, and with the commit graph data structure, is to create a new extra bit of information that essentially says, how high am I in this kind of graphical view? Ignore all the commit date stuff and just use the graphical information to say how high am I. And what essentially it does is it creates these layers where you can say, if you're at this layer, you only go down. All of your edges point down.
Right.
And so this is 1, this is 2, this is 3. And you know that as we explore with this metric, we will never be incorrect because essentially it's this idea called generation number. And so we say that essentially the generation number is 1 more than the maximum generation of my parents.
Okay.
So this is, let's use I. This is I, and it's got J and K. And I say gen J is 10, the generation number of K is 37, and the generation number of I should be 38. Okay, bigger one plus 1.
Right.
And use the thing that if I have no parents, like on the first commit in the rebuild, that my generation number is 1. Which is say you have to start somewhere. But this allows us to say things, well, as I follow these edges down, I'm always decreasing my generation, which allows it to have a nice property where if I can reach something, my generation number is positive.
Right.
And so if you're saying things like, hey, can this commit reach this one? If the generation numbers are backwards, you can immediately say that. Instead of needing to just explore the entire history and eventually explore everything. So one of the things that this makes faster is when you're detecting the fourth book. Say you've got your topic range, you rebase or commit amended, but your remote copy is still the old commit, right? And you're saying, I want to do a push, and it's going to say, hey, does this need to be a fourth push or not? And before, it would say, hey, I can't see these 2 commits. Let me explore all the way down. say, you can't use the commit data as an answer. It has to say, let me go explore absolutely everything until I have no more edges to explore. And then I say, I didn't find that, so it needs to be a fork. But now, if you have generation numbers, you can say, I can just need to explore until my generation is below the generation of the thing that I was looking for. And that can be a much smaller set. So things like fork push, literally big repos can be up to 100, so 1,000. Really where these things come from.
Well, especially on like the big repos you're talking about, that it's huge. That sounds like I'm reiterating the hugeness of repos. So that's really cool.
I do want to say that a lot of these things become really important even at the level of 100 commits, which even moderate-sized teams can do. You have 50 to 100 developers in that same repo, or can get time more easily than other commits.
Oh yeah. Why not just dig into the Apache Cassandra one, or I've had the joy of anybody at Twitter is going to laugh when I say this, but I've had the joy of cloning and then attempting to work with the Twitter repo, the mono repo before, and that thing is a beast unto itself also. But anything that makes those situations more amenable is awesome in my book.
So the one case that's really I would say, the tour de force. It's definitely the most impactful thing I've ever done in the Git code base. If you look at Git log graph, this is my particularly favorite way to explore commit history. Because Git log by default will show you the commits and will use commit date characteristic to list them in order. But if you're in a really big repo where a lot of people are completing pull requests and it branches widely, you've got a lot of independent things that are getting interleaved because they were just because they're committing at the same time.
Right.
And so you're looking through, you're maybe somebody you're looking over a week to create a topic. With 5 commits in it, but those commits are so far apart from the default order. Doing Git log graph, you get something that looks like this. You've got, the PR, number blah, and here's a topic, and then you'll do everything in that topic before you launch the next commit in the history. So it essentially takes everything in here that until everything below here is useful. And it gives you this nice chunking of, all right, when this merged, what did it bring into history? And it shows everything that it brought into history. And it really gives you this idea of, yes, this is logical chunks of information. And it's really helpful when you're doing file history as well. You can see 2 changes that ran into each other. They might actually be independent changes that merge. And it's hard to see without this graphic representation.
Right.
And this is available in the command line. The problem was that in order to do this topological ordering, Git was using concept, which is 3 steps. Maybe just 2, but it was walk the whole graph to compute for every vertex of the graph, what is this indicate? How many edges are putting in? Right. And then you create a queue of the things with in degree 0. So this thing is the one thing with in degree 0. And then say, okay, I'm gonna output it, and I'm gonna decrement the in degree of the things I'm pointing to. Right. And now I have 2 things with in degree 0, and so I'm gonna explore one of them. And then I will say, okay, yes, this thing I can output and mark this thing as a degree 0. And that's essentially what allows you to safely move forward without ever violating the order. And that's the other thing about commit data order, is that you can actually have a parent show up before its child because of the incorrect value. So you would if you ran Git log graph, you would not get a single result until Git explored the entire history. All of it. Which again, even on moderate size repos, that takes several seconds. And so with generation numbers, we're able to do a more intermediate approach. To say, let me explore only the things I need to that are near the top. The thing is that it turns cons algorithms into a very complicated thing where those 2 steps turn into 3, and it's 3 priority queues that are happening simultaneously. Right. Oh, I want to output something here, but I need to explore a little more. Then the next walk needs to explore a little more. The next walk needs to explore a little more. But you essentially have these 3 levels where, hey, at this point, it's safe to make the assumptions above here. If you want to go below, I have to explore more. But it means that you can output the first few results very, very quickly.
Right.
And especially if you're doing a given command line, you get the first page of results right away. And as you're paging through, they will be ready.
Yeah.
And if you wanted to time it, you could say, good luck graph, that's 10. What's the 10 results?
Mm-hmm.
You try it with big graph on or off, you can see the dramatic changes. So this one now is something that I always recommended, hey, try this, but don't do the default, it might be slow. But now I said, yeah, use the default, so I'm going to make that. Mm-hmm. So for people trying this at home, there's ways to make sure you get this in. The good news is that it seems, yeah, it's been accepted so far, I think, in the next version of Git. Maybe will get turned on by default.
Getting my next question already.
Yeah.
This is, where is this in the timeline of us humans using it?
Right. So let's do some checks. So it's important if you're on an old enough version of Git, you will not have it available.
Yeah.
So I would say, I think it's Git 2.20. It has the commit graph. No, 2.19 has the commit graph. Git 2.20 has generation. So as you're building software, you want to be doing the smallest changes possible and shipping it. Mm-hmm. So we didn't do all this at once. So commit graph came around, and then generation numbers were added in a little bit later, and some of the algorithms that Fort Bush was put in there. And then I think 2.21 has the top order of the graph algorithm, the log graph.
Sweet. So
if, depending on what version of Git you have, it may be far enough behind. For instance, Xcode ships with the version of Git that's way behind. It might not be any of these versions.
Right.
And so if you're using a Mac, you'll have to use a secret URL to get a different version that's up to date with 2.23 that so you've upgraded. To enable, you want to use git config, and I always use -- global to make this work in all of my repos. Or .commit graph root. This essentially says, hey, if I have a commit graph file, I want to read it. This will make it aware of, hey, I should try to use this feature.
Is that commit graph space true?
Space true, yeah. Space right here. So core.commit graph is the config setting, and true is the
Very cool.
And this will just mean that Git is now going to be starting to look for this. If it exists. But it doesn't exist. The way we can make it exist is the new commit graph built in. So git space commit-graph write. And by default, it will scan your pack files and find every commit in all of your packs. Mm-hmm. and write a commit graph there. You could also add in, I'm going to put in brackets for the optional -- reachable. And this will only do things that are reachable from your rows. So whatever your branches are. Start with the branches and put it there. This tends to be faster because it doesn't just scan through every object in the repo. And then what you're looking for is inside of your .git folder, inside of the object, it's a super technical thing you don't really need to know what is there. Info, there is a commit graph file, and in 2.23, there might be a thick wraps folder.
I don't want to get into the technical detail for that because it won't show up if you're always using this. So this is how you can make sure it's enabled, and if you want to test like git log graph, there's a trick to turn this config setting on or off. Mm-hmm. So you can say, what effect does this actually have on my repo? Turn the config setting on, run the command, turn it off, run the command again. That's a way you can do a quick test to say how long did that take. And you'll definitely be able to feel it with git log graph. So with 2.24, which isn't out yet, but is coming, this config setting will be true by default. So you can always turn it off if you don't like it. But The reason is why it's from 2.19 to 2.24 before it became a default. It's like we're very safe, wanting to make sure that, hey, this actually is a useful feature for everyone.
Right.
But this will be turned on by default. And also a different config setting called gc.write commit graph will be turned on by default. So whenever your git gc runs and actually is going to do a gc, it would write it automatically. And so you would not need to do this. It would happen as part of your maintenance that naturally happens in a repo.
Cool.
I'm working on a patch to start writing this every time you fetch. So hey, I fetched, I just got new graphs. Let me write more stuff. And that's part of the reason why we kept the commit graphs folder, is that it required a faster write. So the file format got extended to do tiny additional data on top of this big core graph. Because this will rewrite the file every time. And so we want to make sure that write was as fast as possible for most cases.
Gotcha.
So in the future, this is going to get even better and more seamless, and you'll be more up to date more frequently.
Okay. So quick interruption there.
Yes.
For those of you watching, I'll have my audio back up, so I'll intersplice that when I post-process this. And I also changed the mic, so you should be able to hear him not like he's actually on the other side of a 400-foot room. Specifically on topic, if you are using a Mac, always update the stuff and the tools that you use on a regular basis anyway, because most of the stuff needs like 50 patches, or 50 patches behind, or 50 dot versions behind, or whatever. So if you're using Git on a Mac, make sure you go out there and do your brew update, or however you got it on your machine, go update it. I would say the same thing on Windows, but I don't even remember how do you upgrade Git on Windows?
Yeah, for Git on Windows, there's multiple places. If you search for Git on Windows, you will find a place, and some of them are out of date.
Yeah.
The canonical place is GitHub. And I'm going to make this URL, that's the URL, but it's the Git for Windows organization. So git-for-windows/git. This is a fork of git/git, which is the canonical example.
Yeah.
But this has some specific patches for making it work on Windows, including how do we interact with having essentially a version of Cygwin that needs to be installed, and all those other things. The fact that Git is built for Unix machines, translating to Windows Bar. And the releases page always has the most up-to-date versions.
Okay.
So if you go there and you just say, let me go look at the top thing, download an installer, you're good to go.
So there you go. You know where to go get the Windows ones now. So Windows users, go get the Windows, get your Git updated. Get your Git updated.
Right. And the latest is Git 2.23.0 right now.
Cool.
You can always run Git version to check.
Yep. And if you're on Linux, I'm gonna just let you figure that out, because yeah, you should figure it out if you're
It's
using
all
Linux.
sorts of ways. apt-get, if you have apt-get on Ubuntu, that's
apt-get
you're always going to apt-get update and upgrade or install, do it.
Or if you brought it, cloned it, and just built it yourself, and
Yep.
probably got the latest one anyway.
Yeah, if you install it with make prefix equals user developer equals 1, then install. So I know how to install it on my machine locally, but it's not the easiest process.
Yeah.
If you go to Git for Windows Git, and the reason I was specifically pointing there is that we have a custom contributing guide there. It's different than the one in Git/Git. And part of it's because it has custom instructions to get a build environment up in Windows.
Right.
But it also includes instructions about setting up a Linux VM, because a lot of times you want to test Linux anyway.
Right.
Because we're contributing to core Git, we're not making changes just in the Windows side. All these changes are in Git that work on every platform. So there's instructions there about how to get a Linux VM set up, which would include a Linux machine, how to build Git.
And I guess it covers WSL too, then.
Yep, there you go. Whistle is also in there too.
Whistle.
So
Is that how you say that? I gotta say it right.
I have heard Whistle is the way you do it.
All right.
So yeah.
Cool. Very cool.
Which of course that TLA is the Windows subsystem for Linux. So you can have
Yes.
Ubuntu kernel running directly inside your Windows machine without a VM. Yeah.
That you get from the Windows Store still blows my mind.
Right, right.
I'm like, I got Linux from a store. I haven't done that since CDs.
Mm-hmm.
So goes the theory.
I still remember the first time I saw like SUSE Linux in a Best Buy in the
That
90s.
was the one. It was SUSE Linux. I got that on CDs, and it was like 9 CDs because it was a whopper of a of the versions of the distros. But I had a lot of fun trying to make that work. My machine was not very good then, so.
Yeah.
Awesome. Well, I really appreciate you coming all the way from North Carolina to talk to us. And it makes me think of many memories too. I gotta get back to North Carolina sometime. Family's from Wilmington area.
Okay.
On Wrightsville Beach area and all that.
Doing okay with
jazz.
the hurricane?
Well, they don't live out there anymore.
Okay.
So they're actually all out here in the hurricane-less area. And my brother, who actually lives in Boca Raton, or Boca Raton, however you say it, I don't know, I'm not in Florida anymore. He's just chuckling. Another one missed us. But yeah, so everybody I know is not there, but I always love visiting North Carolina. Hadn't been there in probably 3 or 4 years though. So it's a past due trip is what it is.
Yeah.
So thanks for coming all this way up to Ballard, Seattle. I always like to throw the southern accent in there just to confuse everybody.
Right.
Any last words for the audience?
Last words.
Any last minute Git suggestions? Things they should get?
You know, keep an eye out for the release notes and every time get updates because there's a lot of people doing lots of things. In 2023, there's a new set of features called Restore, Git Restore, and Git Switch, which essentially are 2 halves of Git Checkout. Git Checkout does a lot of things.
Yeah.
It's really complicated, and contributor Dewey took the ideas of checkout and split them into 2 different commands, which means that they can be simpler. Git Switch is about changing where head is pointing to, creating new branches. Git Restore is about getting specific versions of files out of revisions without changing where your branch is pointing, which is like the Git Checkout. I don't know if you've ever seen this, Git Checkout revision -- filing. Like that's a thing you can do with checkout. It's really hard, a lot of people don't know that, but Git Restore is going to be the way to do it.
So yeah, I was gonna say, I didn't have file name one.
Right, exactly. So there's lots of different things that are going on, and Git is constantly improving in all sorts of ways. The GitHub blog actually does a really good job of summarizing the new things in every version, so keep an eye out for that. And that way you know, one, you know how to update, to update, and then what other features you're going to get. And it's super helpful.
What Surly Dev asked, what exactly does the Git for Windows repo give you versus the other one?
Sure. Yeah, the Git for Windows repo, it's maintained by Microsoft, and specifically by Johannes Schindelin, who's on my team. And he's been working on this for a long time, and it's essentially, it took a lot of work to get the Unix-isms in the Git code base translated through a compatibility layer into Windows. A lot of that has gotten upstream into Git/Git, but there's still some things that are not quite there. Really there's some things that might never get there because they only apply to Windows, they would never apply to another platform. There's also a bunch of other things that come with the installer that you get in Git for Windows. For instance,
is that like a standard exe MSI type?
Yeah, you download it, it runs through an inode setup installer wizard, and it gives you some options for like, hey, here you might want to use this config setting, or you might want to use this thing that's specific to Windows, but you can opt out of it.
Right.
And that sets up all of the path stuff you need, all of the having a Git bash window. For instance, I don't usually use CMD or PowerShell when I'm interacting on command line. I use Git bash because it also has a full Unix shell script.
Right.
Like I can write bash scripts and I can do all that stuff.
That's been my Windows go-to for ages.
Exactly. So that stuff comes with Git for Windows. It's not actually part of the Git for Windows /Git code base.
Right.
It's in there. There's other repos inside the Git for Windows organization that have all those things, like the SDK for building it, and all these other tools. And so Johannes has gotten this nice pipeline of combining all the tools you need in order to create this installer, so it's a very seamless process. If you tried to start from Git/Git and get that working on this machine without any context, it'd be very difficult.
Yeah.
So I've never done it. I always work out with this, and even when I build my own installer and install my local version and using stuff from that.
Interesting. Very interesting.
Yeah.
My next Windows machine, which I'm like 98% sure it's going to be Windows, won't actually have a need for Git that I know of, because it's going to be a music production machine.
Sure.
But as I do that, I realize there's a bunch of open source music stuff, so I may end up with Git on it
Yeah.
anyway.
Sometimes you just need to get cloned, right?
Exactly.
As a way of getting a software.
Yeah. So awesome. I think that answered the questions, and everybody should feel a bit smarter. So thanks for coming out.
All right. Thank you, everyone.